All right, we're going to talk about the motion of Venus. And Venus is interesting because of its unique nature. So here's Earth, here's the Sun. So Earth is going around the Sun like this. Venus is in here going around the Sun like this. Earth is at 1 AU, Venus here is at about 0.7 AUs. All right, but there are certain positions in Venus's orbit that we notice from Earth. So there's this one position here where Venus goes between the Earth and the Sun. So they make a line across here. This position is called inferior conjunction. Conjunction means that the two objects seem to come together in our sky. And in this case, Venus would be right next to the Sun. We wouldn't be able to see it. For one reason, Venus's side that's lit up is facing away from us, so we wouldn't be able to see Venus anyway. So when Venus is in inferior conjunction, we can't see it at all. When Venus is on the other side, over here, it's still lined up with the Sun. We still can't see it. This is called superior conjunction. Both those are interesting astronomically, but they don't really mean much to people observing the sky. What we really have to do is figure out, well, what's the most interesting thing for Venus? And Venus, the most interesting thing is when it gets at its maximum angle away from the Sun. So when it gets out to here, then we're looking from the Earth. We're going to draw a line like this. Notice that the angle between Earth and Venus, it was going to get bigger and bigger and bigger out to this point here. This is the maximum point. Then as Venus gets in here, the angle gets smaller. So this point here is where it's at the maximum distance it ever gets from the Sun. Or this angle becomes what we call the greatest elongation. Or in this case, this is greatest eastern elongation. And that occurs when this actually makes a 90-degree angle. So the 98-degree angle is focused on Venus and the Sun. Well, the same thing exactly happens down here, right from here to here, except this is greatest western elongation. You're probably asking why eastern and why western? Well, if you're looking at it from the Earth, if we're looking at the Sun, Venus in this case is east of the Sun. In this case, Venus is west of the Sun. Venus, when it's in greatest eastern elongation, is when you're going to see it in the evening sky. And western elongation is when you're going to see it in the morning sky. So that's why Venus has the nickname of being the morning star and the evening star. It depends on where it is in its orbit, which of those positions it's in. Okay? Now, this is where it gets a little tricky here, because Venus takes 224 days to go around the Sun. Earth takes 365 days to go around the Sun. So by the time the Earth comes back to here, Venus has gone all the way around once and more. So it's not in the same position again. Okay, so to get back to the same position doesn't happen every year because it's working at different intervals. But we can measure how long it takes until, if we say greatest eastern elongation, how long is it until Earth and Venus line up to greatest eastern elongation again? And that is actually 583.9 days. Or you would round that to 584 days. We call this the synodic period of Venus. Alright, the synodic period means you measure it by phase to phase. So in this case, from greatest eastern elongation until it gets back to greatest eastern elongation is 584 days, about a year and a half, just a year and 3/4 for that to occur. Okay, that's because as the Earth and Venus are moving, they're both moving together, and so Venus has to get all the way back around to that same position again. That occurs after a year and a half, roughly. Okay, all right. Now you're saying, well, why is that interesting at all? Remember that number, 584. This will become important. 584 days. Venus has something unique, and the Maya people knew this. If you take 5 times 584, and you take 8 times 365, what do you get? All right, well, 5 times 584 gives you 2,920. Remember, this is days. But 8 times 365 is equal to 2,920 days. Wow! What does that mean? That means that if you're watching Venus for 8 years, this is Earth years, Venus will make a cycle in our sky. It'll make these loops in the sky if you watch it every single night. Like you watch it right after sunset, it'll make a loop. And it'll make 5 of these loops, and then it'll repeat exactly those same 5 loops again over the top of it. Now, it's not exact because remember, it's 365.25 and 583.9. So it's a hair off, but it's very tiny amount that they probably wouldn't have noticed. But we know the Mayans realized this occurred. That Venus has an 8-year cycle in which it repeats its motion. Okay? And that will occur if you're the Mayan people and you've watched Venus enough. We know the Mayans are into Venus because they left us written language. So here, I'm going to switch. So hang on, this may be jerky for a second here. I'm going to switch us to the PowerPoint here. Okay. The Maya left us written language. Now, they didn't leave us very many written language. In fact, right now we have what we call 5 codices, 5 significant books. We know they used to have thousands and thousands of these books, but they were destroyed mostly by like Jesuit priests that were bringing Christianity to them. They thought all of the names had these pagan gods and stuff, and so they destroyed them. They burned them and destroyed them. Also, they were made out of bark. They were folded like a fan. And most of the place where the Mayan were is jungle, and so over time, if they weren't destroyed in fires, they were destroyed by just nature. They would just rot away. But there are about 5 codices that we know of, or codices. One of the most interesting one, the best one, is the Dresden Codex. It's the longest one with the most stuff on it. And what we find is, if we look at the Mayan numerals, so you're going to learn how to do Mayan numerals. You're going to learn how to read what the Mayans wrote. The Mayan used a vegesmal system, where we use a decimal system. Decimal means 10, base 10. Theirs is a base 20 system. And this is how they did their numbers. This was their elaborate symbol for 0. Then 1, 2, those were just dots, and when they got to 4, they would add a bar. That meant 5. And then you add a dot onto it until you get up 2 bars is 10, all the way up to 19. And then you would move over 1. So it had a place value system, just like we use today, where we have ones, tens, hundreds, thousands. They had this too, which was very sophisticated because most of the people in the world were not that sophisticated yet. The Roman numeral system, which was what was in use in the Latin area at this exact same time, was very complicated. You couldn't do elaborate math on it because the place values and stuff would get complicated. When we try to multiply, 54 times 23 using Roman numerals, it becomes almost impossible. All right, so now that you know how to read this, let's see if we can read part of a codex, or we can see it. This is part of a codex. This is off a stela. You see, these are numbers. That number right there is 16. That number is 5. That number is 8, 9. So you can read these numbers. These are all numbers right here. Okay. Now, you're asking why would we care about that? Well, look, in the Dresden Codex, right here, there are many pages in this thing. It's several hundred pages long. But there's many pages in here, and it's devoted to Venus. And you can read these over here, right? These are zeros, that's 16, so on. And we wonder, well, what did all those numbers mean? Well, you look right here. This is page 48 of the Dresden Codex. These are dates in their calendar. We're going to talk about their calendar a little bit later. But these are totals, so they summed up the number of days. And you're saying 236 plus 90 plus 250 plus 8. What is that? That's 584. Oh, son of a gun, 584. Look right here. Can you read this? 584, I'll do it off the side. 584 is the synodic period of Venus. So this 236 days, that's how long it takes Venus to go from greatest eastern elongation back to greatest western elongation. Okay? I'm sorry, from greatest eastern elongation to superior conjunction is 236. Then when it's behind the sun, we lose it for 90 days because as it's behind the sun, we're also moving, so it takes a long time to come out on the other side. Then it takes 250 days to get up to greatest eastern elongation. And then it passes us in inferior conjunction in 8 days. So if you total all those up, it comes to 584 days. So they knew exactly what this 584 was. In fact, this is not the only page. There's several pages up where whoever was writing this book was actually marking the position of Venus on every day and then totaling up the number of days until it got back to that same position. So we know they knew about Venus. Not only did they know about Venus, but they had an observatory. This is called Archaeoastronomy, which is a Spanish name. It's not a Mayan name. That's it right there, okay? This is the remnants of it. This is also in Chichen Itza. It's in the same complex where the Temple of Kukulkan is. You just have to walk, it's about a half a mile away or so. All the buildings that were left over, these are the remnants of it. But in the top of this building, up here, which is kind of ruins right now, but in the top of the building, there were windows. And those windows, this is a picture from the inside going up. You can see the windows up here on the top, okay? From these windows on the inside, you can look out through these slots. This is the equinox sunset, which would be straight